All right, this is the Honors Algebra 1 flip class video for section 9.7. We're going to start out with an application with the vertical motion model. Just a reminder that the vertical motion model is h is equal to negative 16t squared plus vt plus s. Remember that the h stands for height at a particular time. The t stands for time. Both t's do. The v stands for starting velocity, and the s stands for starting height. Okay, let's take a look here at number 1. It says a grasshopper jumps straight up from the ground with an initial vertical velocity of 8 feet per second. We'll write the vertical motion model for the grasshopper. So the vertical motion model, typically we fill in for v and we fill in for s. So there's the v, there's the s. So it looks like this. H is equal to negative 16t squared plus 8t plus 0. Now I know that the starting height is 0 is because the grasshopper jumps straight up from the ground, and then the initial vertical velocity is 8 feet per second, so that's why we plug in an 8 for the v. Okay, so part B says after how many seconds is the grasshopper 1 foot off the ground? We're pretty used to the question being after how many seconds does the grasshopper land. That's not the question here. How long until the grasshopper is 1 foot off the ground? So what I'm going to do is I'm going to plug in, instead of a 0 for h, I'm going to plug in a 1 for h. So it's going to be 1 equals negative 16t squared plus 8t. Remember, our starting line for these polynomials is to have everything on one side equal 0. And so I'm just going to subtract the 1 from both sides. So I'm going to get 0 is equal to negative 16t squared plus 8t minus 1. Okay, so in order to solve a polynomial, it has to be in factored form, so we can use the zero product property. We've talked about this before. We talked about this in 9.6. We've got a trinomial, and a is not 1. As a matter of fact, a is negative 16, and I'm not a big fan of a being negative. So what I'm going to do is I'm going to multiply everything through by a negative 1. You could also divide everything through by a negative 1. And so what that is going to do is that's going to change all my signs. So I'm going to get 0 equals positive 16t squared minus 8t plus 1. Okay, so if I'm going to factor when a is not 1, the first thing I've got to do is find AC. AC is 16. So I need to think of which factors of 16 also add to be negative 8. So, and the method I'm going to use here is split the middle. We talked about that in section 9.6. Okay, so, 2 times 8 is 16, but 2 plus 8 is 10. So maybe we could do negative 2 times negative 8. But negative 2 plus negative 8 is negative 10. We're looking for negative 8. So maybe you've already thought of it. If not, here it is. It's negative 4 times negative 4. That'll give you positive 16, but when they add to be negative 8. So we're going to split the middle. Looks like this. 16t squared minus 4t minus 4t plus 1. Remember, we're just splitting the middle so that we have something that will factor, and still, the b term is still the b term. It hasn't changed value. Okay, once we have done this, we're going to group. Don't forget to put a plus sign in between the groupings there. We're going to factor out a GCF from each of the groupings. So we come up here, we get 0 is equal to, what I'm going to do from the first grouping, I'm going to pull out a 4t. So 4t, what's left over is 4t minus 1. Now remember if you remember from section 9.6, we want the leftovers to match. So on this binomial, I'm just going to factor out a negative 1. So it's going to be minus 1 parentheses positive 4t minus 1. Factoring out a negative 1 simply changes the signs. Okay, and then lastly, I'm going to recognize that I have the common factor of 4t minus 1 in both of these. So it's going to be 0 equals 4t minus 1. And now check it out, the leftovers are actually the same as what we just factored out. Okay, so I can set each factor equal to 0 now, but the truth is, since the factors are the same, I only need to set one of the factors equal to 0. I get t is equal to 1/4. So after 1/4 of a second, the grasshopper is 1 foot off the ground. Okay, so we're going to work through a few other examples here, some special factorings and whatnot, but I want to introduce this to you, something we came up with in recent years called the factoring decision tree. Sometimes it can be kind of complicated to decide what to do. Once you get to the what to do, the how to do it, usually folks are pretty good at, but the getting there is a pretty important piece. So we're going to try that here with number 2. So number 2 is 25x squared minus 81. So I'm just going to write that over here. We're supposed to factor this. And we're going to always start here and go from left to right. So my first step is to factor out the GCF. So between 25x squared and 81, there actually, in this case, is not a GCF. And that's okay. We just say, no, there's not a GCF. We're going to keep going. Next decision, 2, 3, or 4 terms. I see 1, 2 terms. So 2 terms means we're going to use this upper branch. We're going like this, going 2 terms. Our next question is it the difference of squares? And this is a term we have not talked about yet, but it's pretty easy to actually understand. Difference means subtraction. So do we have subtraction? Yes, we do. And then is it the subtraction of 2 perfect squares? Well, if you think about it, 25 is a perfect square, and x squared is a perfect square, and 81 is a perfect square. So we do have the difference of squares. And so since the answer is yes, we're going to factor using the plus minus pattern. You might remember this pattern from back in section 9.2, I believe. Maybe it was 9.3. So here's how we do this. We're going to go 2 sets of parentheses. We're still unfoiling here. 25x squared is really just 5x times 5x, and 81 is just 9 times 9. And since it is the difference of squares, we'll always follow the plus minus pattern. So it's going to be 5x plus 9, 5x minus 9. So as far as factoring goes, that's all we'd write. 5x plus 9, 5x minus 9. Recognizing that can be a challenge at times, but if you follow your little factoring decision tree, it should be a help. Okay, check out number 3, 9t squared minus 12t plus 4. So let's see what that looks like over here. So 9t squared minus 12t plus 4. Okay. All right, let me get rid of this old path here. And here we go. First step is to factor out the GCF. So if you look at all the terms here, 9, 12, and 4, there's no common factor there. T squared, t, and then there's no common factor there either. So there is no GCF, and that's okay. So we're going to go 2, 3, or 4 terms, and there's 1, 2, 3 terms. This is a trinomial. We're going to follow this pattern here. The next question you're asked is the a value 1. So remember, it's ax squared plus bx plus c. So your a value in this case is 9. So when it says is a1, we're going to say no. So here's our method, split the middle. All right, so to split the middle, we got to find, well, actually I'll come back over here. We're going to split the middle. I have a little more room over here. So the first thing we're going to do is we're going to find AC. So AC is 9 times 4, that's 36. So we got to figure out which numbers multiply to be 36 and add up to be negative 12. So, you know, there's 9 times 4, those add up to be 13. There's 3 times 12, those add up to be 15. We're looking for negative numbers anyways. 6 times 6 is 36, and they add up to be 12. So if I just go negative 6 times negative 6, that's going to work. So splitting the middle, I get 9t squared minus 6t minus 6t plus 4. Once you've split the middle, you always group. So I'm grouping my first and last pairs. I'm going to factor out the GCF. So here, in the first pair, I see in common a 3 and a t. So what's left over is t minus 2. Okay, so once again, we want the second pairing to have the same leftovers. So I could factor out a 2, but then my signs will be off. So I'm going to factor out a negative 2. Oops, sorry, I lost a 3 there. So when I factor out a negative 2, Out of a negative 6, I get 3t in this case. Factor a negative 2 out of a positive 4, I get a minus 2. Now you can see my leftovers match. Okay, I'm going to factor out the leftovers, so it's going to be 3t minus 2. And look at that, kind of like we saw earlier, the leftovers match the leftovers. So we get 3t minus 2, 3t minus 2. You could rewrite this to be 3t minus 2 squared. All right, moving on. We're going to factor one more, and then we're going to do a few solvings. Okay, so I'm going to go over to the factoring decision tree here. We've got 4n squared minus 40n plus 100. So, oops, 4n squared minus 40n plus 100. Okay, let me get rid of this old stuff here. All right, so first thing we're going to do is we're going to factor out the GCF, and so far we haven't had one. But maybe you've already seen with this one, we will have a GCF. It's a 4. There's a 4 in common. So I'm going to write down what's left over. It's n squared minus 10n plus 25. Okay, so we've done this. We've factored out the GCF. Now we've got to go 2, 3, or 4 terms. To start here, we go here, and hopefully you recognize that we have 3 terms. So our next question is A1. A is 1, right? Because it's 1n squared. So we are going to go this way. We're just going to use the factors of C. All right, so which numbers multiply to be 25? Add up to be negative 10. Well, gosh, 25 doesn't have very many factors. I mean, there's 25 times 1. That's 26. It's not even close. There's 5 times 5. That's 10. So that doesn't work, but negative 5 times negative 5 will. So our final factoring would be 4 parentheses n minus 5. N minus 5, or you could write 4 parentheses n minus 5 squared. All right, hope this is making sense to you. Let's take a look at number 5. All right, this one says solve, so in the end we are going to take this all the way to a solving step. Okay, 36m squared minus 64. Oops. So 36m squared minus 64. Okay, so step number 1, factor out the GCF. So is there a GCF? Is there a greatest common factor? Well, there is. It actually happens to be a 4. I forgot my equal 0. There we go. So we factor out a 4. So it's going to be 9m squared minus 16 left over on the inside. Okay, so we start here, factor the GCF. 2, 3, or 4 terms. Well, there's 2 terms in there. Now let's decide if it's the difference of squares. So remember, difference of squares means subtraction, which we have, and it means the subtraction of 2 perfect squares. Well, 9m squared and 16 are both perfect squares, so I would say yes, this is definitely the difference of squares. So we'll factor with the plus minus pattern. Just a reminder, here's how that works. The 4 doesn't disappear. We're unfoiling, so we get this a set of 2 binomials. Here's how we go. 9 is 3 times 3. M squared is m times m. 16 is 4 times 4. Now we just use the plus minus pattern. So since we're supposed to solve this, we're going to take it one step further and use the 0 product property. Set each factor equals 0. So 4 equals 0, that's not true. 4 doesn't equal 0, so that is not a solution. But 3m plus 4 equals 0, that's going to work. 3m minus 4 equals 0, that will also work. Over here we're going to get m equals negative 4/3. Over here we're going to get m equals positive 4/3. So your final answer is m equals plus or minus 4/3. You can write it this way, you can write it this way. Either way is fine. All right. Take a look at number 6. Number 6, x squared plus 14x. Boy, this doesn't look right, does it? I mean, it doesn't really look like what we're used to, because aren't we used to having everything on the same side equal 0? Let's go ahead and fix that. We just need to go plus 49 and plus 49. So it's going to be x squared plus 14x plus 49 is equal to 0. So I'm going to go back to my factoring. decision tree. And by the way, this factoring decision tree is on your Net Classroom. You can print it off. You can use it in your homeworks and things like that. But let's try to internalize this. Let's try to get it to a place where you can understand this without having it in front of you. Okay, so this is what we ended up with. Let's just double check. Yep. Okay, so start off here. I'm going to factor out a GCF. Is there anything in common? We've got x's in the first two, but not in the third. We've got 1, 14, and 49. I don't see a common factor. So we're moving on. 2, 3, or 4 terms. There are 3 terms. Is a 1? In this case, a is 1 because it's 1x squared. So the answer is yes. So we're just going to use the factors of c. All right, so which number is multiplied to be 49? Again, there's not very many. There's 49 times 1. There's 7 times 7. Which of those is going to work? Well, the first one definitely doesn't work because 49 plus 1 is 50, and we're looking for 14. 7 times 7 does work because 7 plus 7 is 14. So this will factor is x plus 7 equals 0. And so you only really have to set one of those factors equal to 0 because they're the same. So x plus 7 equals 0, x equals negative 7 would be your final. Okay, there we go. One last just skill-oriented example here. 8w squared equals 50. Once again, we don't have the kind of the normal starting line here, so I'm going to subtract 50. We really want to have the polynomial equal 0 for this to work, at least how we're accustomed to. So 8w squared minus 50 is equal to 0. All right, here we go. 8w squared minus 50 equals 0. First thing we do here is factor out the GCF. So what's in common between 8 and 50? I think it's only a 2. And we don't have a common w, so I'm just going to start my parentheses here. So I had an 8 factored out of 2. I've got 4, so I've got 4w squared. I factored a 2 out of the 50, so I got minus 25 equals 0. Continuing on, 2, 3, or 4 terms. There are 2 terms. The big question here is, are those 2 terms the difference of squares? And I think they are. Remember, difference means subtraction, which we have. And squares means perfect squares. Well, 4w squared is a perfect square, and so is 25. So our decision here leads us to factoring using the plus-minus pattern. So we set up our unfoil. 4w squared is really just 2w times 2w. 25 is just 5 times 5. Here's the plus-minus pattern. Okay, so since we're supposed to solve, we're going to use the zero product property, set each factor equal to 0. So I'll just go down here. 2 equals 0, not true. That's not one of our solutions. But 2w plus 5 could equal 0, and 2w minus 5 could equal 0. So if I come back up here, I'm going to get w is equal to negative 5 halves. W is equal to positive 5 halves. Of course, you could just write it like this. That's just as good. Okay, let's take a look at a couple of applications here. The first one is geometry. It says a circle has an area of 144 square centimeters. The radius is x plus 4. What is the value of x? So let's remember that the area of a circle is pi times radius squared. So I can fill in quite a few blanks here. I can fill in the fact that the area is 144 pi. I can also fill in the fact that the radius is x plus 4. So that would be my starting, my setup, my start there. I see that there's a pi on both sides. So before we get going too fast, I'm just going to cancel out. I'm just going to divide both sides by pi. Make it a lot easier on myself. Okay, now on the right side, x plus 4, a binomial squared. We're going to expand, then FOIL. So it's going to be 144 equals x squared plus 8x plus 16. And then I need to subtract 144 from both sides because I want to get to everything on one side equals 0. So it's going to be x squared plus 8x minus 128 when I factor out, or excuse me, when I subtract the 144 from both sides. Okay, we'll do a quick decision tree here. We've got, let me just make sure I've got this right again, x squared plus 8x minus 128. All right, so factor out the GCF. Well, there isn't one. They don't all have an x. And there's nothing in common between 1, 8 and 128. 2, 3, or 4 terms. There are 3. Is A1. A is 1. So we're going to use just the factors of C. Number's kind of big here. If you want to, it probably would be a good idea. Pause the video, try this, you can figure it out on your own. Restart the video and see how you did. I think our right answer is going to be negative 8 times 16. Yeah. Because that multiplies to be negative 128, but it adds up to be 8. So it's going to be x minus 8, x plus 16 is equal to 0. So using the 0 product property, x minus 8 equals 0. X plus 16 is equal to 0. So x would end up equaling 8, and x is equal to negative 16. Negative 16 doesn't make any sense. You can't have a negative radius of a circle, and so we just only take the x is equal to 8. All right, last one. Measuring tape drops from a roof that is 16 feet above the ground. After how many seconds will the measuring tape hit the ground? So this is one of those cases where we're going to use the h is equal to negative 16t squared plus vt plus s, the vertical motion model. Typically, remember, we substitute in for v and s. So v is kind of an interesting one because it says the measuring tape drops. That means that whoever had it in their hand didn't throw it, didn't kick it, didn't do anything with it other than just drop it. And so the honest truth is, when they drop it, the starting velocity is just 0. And the starting height was 16. So I could rewrite this to be h is equal to negative 16t squared plus 16. I can just get rid of the 0 entirely, because 0 times t is 0. Okay, after how many seconds will the measuring tape hit the ground? Well, this is where height is 0. So 0 is equal to negative 16t squared plus 16. Let's see if we can remember that decision tree. First thing we do is we factor out a GCF. And I noticed that both terms, there's 2 of them, of course, I see both terms have a 16. There's a negative 16 here, and I don't like my a being negative, so I'm going to factor out a negative 16. What's left over is t squared minus 1, because I factored negative 16 out. What's left over? Is it 2, 3, or 4 terms? It's 2 terms. The next question is it the difference of squares? And you can see that it is, because it is a difference. We have subtraction. T squared is a perfect square. 1 is a perfect square. So we set up our binomial with t's in the front, 1's in the back, plus 1, minus 1, the plus minus pattern. So now we're going to come up here and set each factor equal to 0. Negative 16 equals 0. That is not true, so that is not a solution. But t plus 1 could equal 0, and t minus 1 also could equal 0. For our final answers, we're going to get t equals negative 1, t equals positive 1, but the t equals negative 1 doesn't work because negative time is not going to work for us. We're going to exclude that, but we're going to keep the t equals positive 1. Hope this has worked for you. Hope you've learned all that you can. We'll see you next class.